I welcome all of you who are interested in understanding this particular concept in maths. Okay, so this is our question, but just before we look into that question, I would like to show you the types of graphs that we will be doing this year. Okay, so it's linear. We'll revise linear graph. We have been doing linear graph from year 9, 10 and last year, which is in the form of y equals mx plus c. And to sketch the graph of a linear function, actually there are three methods that we can use, which are graphical method. We can use the table of values method, where we choose some values of x and substitute it in place of x in the given equation. Then we will find some values of y. Then from there you will have some coordinates. Then you can plot your linear graph. Or the intercept method, where you can just find the x and y intercept, then you plot the graph. That is for linear graphs. For quadratic graphs, so far we have been solving and plotting graphs of quadratic functions that are in this form: y equals ax squared plus bx plus c. And questions which are given in this form for quadratic, usually we factorize it. Remember, quadratic function, the highest power is 2, so that means we will have 2x intercepts. Okay, for linear function, there's only one x there, the highest power is 1, so only one x intercept. For quadratic, the highest power of x is 2, so we will have a 2x intercept. And this is how we actually solve it. In order to sketch the graph, we factorize the given equation. Then from there, we can find the 2x values and our y-intercept. So 1 y-intercept, 2x intercept. Then we just join them and we can form our quadratic graph. Okay. But for questions under quadratic graph which are in this form, you cannot factorize it. That is where we will use the quadratic formula. But last year you were introduced with the general form of a quadratic function. And the question that I'll be explaining today is from that general form of quadratic functions or in quadratic equation. And the general form of quadratic equations are like this: y equals plus or minus a, then inside the bracket x plus or minus b squared plus or minus c. Don't worry about the plus and minus, because the question depends on the question. Whether our a will be positive, then we'll take the positive of it. If our a is negative, then we'll take the negative of it. Likewise in plus or minus there and the plus and minus there. Okay, so looking at our question, it is exactly in this form. So from there we can see that our a is 2, our b is 1, and our c is negative 4. Okay, but before we actually look into that and answer the question, I'll just like to note out the meaning of this a, b, and c. What is the meaning of it? Before that, there's a plus and minus there. This plus and minus, it goes for the sign of our a. If our a is positive, then that means, since this is a quadratic equation, and we all know for quadratic equation, the graph is a U shape. If our a is positive, then it will be like this, upward U. So this is if our a is positive. The value of a is positive, then it will be like this. If the value of our a is negative, because that will make the whole equation negative, and the positive will make the equation positive. So if it is negative, then it will be an inverted U shape. Some people say V shape. Okay, so that is the meaning of that plus and minus. Positive, if it is a positive a, then our graph, the shape of our graph will be like this. If it is negative, then it will be the other way around. Okay, so a, the value of a. What is the meaning of value of a? The value of a is the stretching of our graph. So what is the meaning of this stretching of graph? I will show it to you. The stretching of graph from the original quadratic graph, that is y equals x squared. So y equals x squared. When we will actually sketch the graph, we will always start with this graph, then we will shift according to the question and the stretching. So if our a is greater than 1, the value of our a is greater than 1, so that means from this graph, from y equals x squared, that is where we will start off. From that, our graph will be narrower than that. For example, this is our graph, our y equals x squared graph. This is it. So if the value of our a is greater than 1, then from there our graph will be narrower than that. So it will be narrower than that. So that will be our new graph. Then from there we will shift along the x-axis and shift along the y-axis according to the question. This is when our a is greater than 1. So this is the normal y equals x squared graph. Then it will be narrower than that if our a is greater than 1. But if our a is less than 1, if our a is less than 1 but greater than -1, if it's in this interval, then this is how our graph will look like. So this is the normal y equals x squared graph. This is the normal y equals x squared graph. Let me just write y equals x squared there. That's the normal y equals x squared graph. But if our a is less than 1 or greater than -1 between this interval, then it will be wider than that, wider. So we can conclude if our a is in this range, then it is narrow. If our a is between this interval, then it is wider. Okay, so that is the meaning of stretching there, our a value. And x plus or minus b, this is the shifting along the x-axis. So I'll just write x-axis there because it's the shifting along the x-axis. And our c is the shifting along the y-axis. Okay, how many units to shift on the x or how many units to shift on the y-axis, that will depend on the question. So now we go back to our question. Our question is y equals 2 into x plus 1 squared minus 4. Comparing our question with the general form of a quadratic equation, we can see that the value of our a is 2 and our graph, it's a positive u, so it will go this way. So let us just start with what we usually start with when we sketch the quadratic graphs. As I've already told you, we will always start with this function y equals x squared. And if you want to know the coordinates for this, in order to sketch, to start with, you can use your table of value method. So the table of value method, x value and y value. So let's just choose. I'm just showing you this so that you know where did I get the coordinates from. -2, -1, 0, 1 and 2. Okay, so if we put -2 there, bracket -2 squared will give us 4. If you put -1 there inside the bracket, -1 squared will give us 1. If you put 0 there, it will remain as 0. If you put 1 there, 1 squared is 1, 2 squared is 4. So the coordinates are there, -2, 4, -1, 1, 0, 0, 1, 1 and 2, 4. So let's just sketch that because we will start with this graph, then we will do the shifting and the stretching and the rest of the things. So -2, 4, where is -2, 4? -2, 4 there. -1, 1, -1, 1 is there. 0, 0, the origin. 1, 1, so 1, 1 and 2, 4. The last one, 2, 4. So the graph that we will start with, that is the y equals x squared graph. This is it. So it's like this. So we will start with this graph, then we will do the stretching and the shifting. Okay, from there, remember our graph is the symmetrical line is there. It is symmetrical. Okay, so both sides are equal. This graph y equals x squared graph. So from here, so here we can see the shape is positive. Okay, that's correct. Now we move to a. Our a is equal to 2. So that means our stretching this graph, we will multiply it to 2. So that means it will be like this. 2 times x squared. It's like this. Y equals 2 times x squared. So this x squared graph, we will multiply it by 2. That is the meaning of these two, and that is the meaning of stretching. But remember, this value, our a value is greater than 1. So that means this normal y equals x squared graph, our graph will be narrower than that. It will be somewhere inside. Okay, so this is how you will do it. So we choose x value. So if we choose 0, let's use our x value, say 0, 1, 2. Okay, if we put 0 here, 0 multiplied by anything will still be 0. So that means it will still be 0 for 0. But when x is equal to 1, it will be 2 multiplied by 1 squared. That will be 2 times 1, which is 2. So that means the new coordinate now is this is when x is equal to 1 is 1, 2. So 1, 2 is there. What I'm doing now, this is the stretching part. When our a is 2, this is the stretching part. It will be narrow. It will be narrow. So it will be inside here, because according to our rule here, when our value of a is greater than 1, it will be narrow. Our a is actually greater than 1 because it is 2. Okay, let's choose for 2. When our, so it is 2 multiplied by x squared. When our x is equal to 2. When our x is equal to 2, so that means 2 multiplied by 2 squared. In place of x, I'm putting 2 there. So that means 2 multiplied by 4, which is 8. So that means when our x is 2, when our x is 2, our y will be 8 there. Since this graph is symmetrical, whatever point beside, you will also get it on the other side. But you can try the value if you want to see. Just for your satisfaction, I'll do that part. So let's try for -1 and -2. So y equals 2 multiplied by x squared. When x is -1, that will be 2 times -1 squared. So you can see -1 squared is 1. It's also 2. So when x is -1, our y is 2. So -1 and 2, it's there. And for -2, I'm out of space. 2 multiplied by x squared. When x is equal to -2, so it is equal to 2 multiplied by -2 squared will actually give you a positive number, which is 4, and 2 times 4 is also 8. So there you go, -2, 8. And that is it. We started with this graph. This graph is y equals x squared graph. Then according to our a, which is 2, our stretching will be, it will be narrowed. So this is our new graph. Our new graph is narrowed from the y equals x squared graph. So this is our new graph. Remember, this U shape, it just say U. So you know it's this shape, but you don't know if it's narrow or wider than the normal U you usually draw. So this is how you determine it. We look at our A, then we do it like this. If the value of our A, let's take for example, if the value of A was 3, then we multiply 3 with this graph x squared. 3 multiplied by x squared, then you'll do the same thing. Or any other number, if it's a negative number, you will also do the same thing. But remember, if it's in this interval, then it will be wider. If it is greater than 1, if our A is greater than 1, then it will be narrow from the y equals x squared graph. So from this graph, the one in black, then we will do the shifting along the x-axis and the shifting along the y-axis. So from this black graph, then first we will shift along the x-axis. And what is the shifting? X plus 1. So we are shifting along the x-axis. That means we have to know the value of x. Okay, so our expression here is x plus 1. In order to know the value of x, you just make that equal to 0. Then you can calculate your x. So x equals 0 minus 1. So x is negative 1. So this simply means your shifting along the x-axis will be 1 unit to the left because it is negative 1. So negative 1 is there from this graph, then 1 unit to the left. So your graph will be something like that. Remember, it will not be accurate because you are just sketching it. So it will be narrow from the y equals x squared graph. So from this graph, the one in black, then you shift along the x-axis already. How many units? 1 unit to the left because our x is negative 1. That is the shifting on the x-axis. Then the last part, shifting along the y-axis, it is negative 4. So that means 4 units down. So from here, 1, 2, 3, 4. 4 units down. So this shape of your graph, you just bring it down. Remember, it should be narrow because our a was greater than 1. And that's it. So this is our graph of y equals 2 into x plus 1 squared minus 4. This is its graph. But remember, during exam, you need to show all this sketching. Starting from y equals x squared, the one in red, then we stretch it looking at our a. So our a is greater than 1, so it will be narrower than that. So the narrow part is in black. Then from here, the one in black, then we shift 1 unit to the left. After that, then 4 units down. So this is our final graph. After all the shifting and stretching, our final graph is the one that is in bold. Okay, I hope you can clearly see that our final graph is the one in bold. So we started with y equals x squared, the one in red. Then we stretch it. Our a is greater than 1, so it will be narrower than that. And we do the calculation for it. And we found the coordinates. So from this black, then we shift 1 unit to the left. Because our x is negative 1, 1 unit to the left. After shifting along the x-axis, then we shift along the y-axis. Y-axis is the vertical axis. So we are going down because it's negative 4. So 4 units down, 1, 2, 3, 4. Then this is our final graph, the one in bold.